All right, in this I want to talk about the 2004 Calculus BC exam, Form B, question number 2. This is the Taylor series question for this exam, and a calculator is allowed on this problem. Not sure it's going to be needed much, but you are allowed a calculator as a security blanket, I suppose. So let's look at this one. You are given a third degree Taylor polynomial for an unknown function f. The center of the Taylor series is 2. You always want to make note of things like that. It's about x equals 2. Um, and here is a Taylor series. And the first two questions are fairly straightforward. Find f of 2 and f double prime of 2. Notice it didn't say estimate. You're getting exact values here. And one thing to remember with Taylor series is when you are at the center of the series, your Taylor polynomial does give you exact values for the function. So f of 2 is going to be pretty easy. We are simply going to plug 2 into my Taylor series, which would be 7 minus 9 times 2 minus 2 is 0, minus 3 times 2 minus 2 is 0, and 7 plus all those zeros is 7. So there's your f of 2. So f of 2 is going to equal 7. F double prime of 2, there are two ways you could do this. Because the Taylor series is exact at the center, you actually could find the second derivative of t and plug 2 into that. However, a quicker way to do that is to remember that the coefficients of a Taylor series are found by the formula f to the nth derivative, or f to the nth derivative of f at the center, which in this case is 2, over n factorial times x minus a to the n. And in this case, a is 2. And so here, if I want the second derivative of 2, the second derivative of f at 2 over 2 factorial times x minus 2 to the second power, that would give me my second degree term, which would be negative 9 times x minus 2 to the second power. The x minus 2 terms can divide out, and so what we're left with is f double prime of 2 over 2 factorial equals negative 9. And if you multiply both sides by 2 factorial, which is just 2, you get f double prime of 2 is equal to negative 9 times 2 factorial, which is negative 18. And so there are your answers for part A. Part B, is there enough information to determine whether f has a critical point at 2? Now remember, a critical point. Don't let the fact that this is a series question make you forget what a critical point is. So essentially what this question is asking is whether f prime of 2 equals 0. So is f prime of 2 equal to 0? That's what this thing's questioning. Says if not, explain why now. I think that should be a T. There we go. Explain why not. And if so, determine whether we have a max or min. So first we're going to find f prime of 2. And I'm going to do that the exact same way I found f double prime of 2 and f of 2 up in part A. So f prime of 2. And if I use my Taylor polynomial formula, f prime of 2 over 1 factorial times x minus 2 to the 1th, or to the first, if I look at my series, there is no x to the first term. So that means this thing needs to equal 0 because we skipped that x minus 2 to the first term. And so that means the only way for that to happen is for f prime of 2 to equal 0. So that is true. And so now that we know that is a critical point, that means this is a candidate for a max or a min. And so now we need to justify the local extrema activity of the function at x equals 2. And the easiest way to do this one is to look up at part A. In part A, we already established that f double prime of 2 is negative 18. So since f double prime of 2 is negative 18, that tells me that at x equals 2, the function is concave down. And if a function is concave down at a critical number, this thing must be at a local max. So negative 18 is less than 0. Therefore, f of x has a local max by the second derivative test. second derivative was negative at 2, so we know we're concave down. We already established that the slope at 2 is 0, and the only way that happens is if you're looking at a local max. You probably could have, if you want to make things difficult on yourself, found the derivative and done some sign analysis, did the first derivative test, but this is by far the easier way. So let's look at part C. Same function, so now we're using t of x to approximate f of 0. That's going to be easy. We're just going to plug 0 into this function. So t of 0 is going to equal 7 minus 9 times 0 minus 2 squared minus 3 times 0 minus 2 cubed. And we can throw that in the calculator to get a value. And when you plug that into a calculator, you will get t of 0 is negative 5. Now remember, that's an approximation for f. That's not exactly f of 0. And I probably should, I'm going to change the way I wrote this. We're estimating f of 0, so I'm going to change this to f of 0 is approximately that. So f of 0 is approximately negative 5. Is there enough information to determine whether f has a critical point at x equals 0? If not, explain why not. If so, determine whether we have a max, min, or neither at this place. And this one's going to be a little bit easier than the last one because the answer is no, there is not enough information. So not enough information. So there's not enough information. And the reason there's not enough information is because I have now gone away from the center of my series. You're still allowed to use the Taylor polynomial to approximate function values, and notice I did use the word approximate here, but the instant I step away from the center of the series, everything's an approximation, and I'm not going to be able to get the exact value of the derivative at 0 because it's not the center of the series. And so not enough information because t of x only gives exact information for the center, which is x equals 2. There you go. And so let's look at part D. The fourth derivative satisfies that inequality for all x's on the closed interval 0 to 2. Use Lagrange error bound on the approximation of f of 0. So we estimated f of 0 to be approximately negative 5. So f of 0 is approximately negative 5. And we need to use the Lagrange error bound to explain why f of 0 is negative. Okay, so with Lagrange, the formula, or at least the formula I use, some other teachers may use different notation, but your remainder in using the third degree polynomial to estimate f of 0 is less than or equal to m over n plus 1, which would be 3 plus 1 factorial times x, which I plugged in 0 minus the center to the 3 plus 1 power. And so there is your formula for Lagrange. And the challenge most of the time with Lagrange, or Lagrange, or Taylor's polynomial, whatever you want to call it, or Taylor's inequality, I mean, is finding the m. However, they're extremely nice here because when they told you that the fourth derivative was always less than or equal to 6, they are giving you that value of m. So we now know that m is 6, so I can plug that in down here. And now we're simply going to throw this in the calculator to get an upper bound for my error. Alright, so we punch all that in and we get my maximum possible error of 4. And so there's our Lagrange upper bound. Then we need to use that to explain why the value of f of 0 is negative. Now remember, my Taylor polynomial gave me an approximation, and my approximation was negative 5. So if I want to know why my function must be negative, well, if I got an estimate of negative 5 and the largest possible error is 4, well, that error is not enough to bring negative 5 up into positive numbers. The way I would write this mathematically is f of 0 must be less than or equal to my Taylor approximation plus my maximum error, r sub n of r sub 3 of 0. So if I take my approximation, which was negative 5, and I add the largest value, or the largest error I could have, I get f of 0 must be less than or equal to negative 1, which is negative, right? Which is less than 0. Therefore, f of 0 must be negative. There we go. So there, I wanted to do this problem specifically because it had a Lagrange reference in it. And as long as you can keep the formula for Lagrange straight, recently on the AP exam, they've been very nice to you about that value of m, and it's just a matter of plugging that in and using it to answer whatever question they have for you. As far as point value, here are the point values for this one. I'm going to bring this over here. Part A, you got 1 point for f of 2 and 1 point for f double prime of 2, 7 and negative 18. Part B, you can see their answer. There is a critical point at 2. They, again, used the second derivative test. They didn't explain that it was a second derivative test, but they have the work shown. You got 1 point for each of those. C, 1 point for t of 0 being negative 5. 1 point for declaring that it's not possible, and then 1 point for the reason. And then D, your Lagrange problem, 1 point for getting the value of 4, and then 1 point for your explanation. And there you go.